Now let's look at a special case of the Bitcoin script programming language. Let's look at how to insert data into the blockchain. So you know how to send amounts to somebody else, send smileys or send Bitcoin or send Litecoin to somebody else. It's also possible to send data, and let's look at that. So we want to use the command create raw transaction to do this completely from scratch, and rather than use it inside a Windows or Macintosh user interface, I'm just going to do this completely directly from the command line. So we check first, do we have any smileys? Do we have anything to send? And the easiest way to do that is to use the getinfo command. Now, in the most recent versions of Litecoin and Bitcoin, there is no getinfo command, so you may want to use getBalance instead, but that's beside the point. We have 84 smileys here, so let's check which transfers, which transactions correspond to these unspent transaction outputs that we have. And in this particular case, we're lucky there's only one transaction which has sent us these 84 smileys. And if we were to go into a block explorer and check this transaction ID, we would see that it has output number 1 destined to this address with an amount of 84 smileys. So now we can set up a transaction which takes this particular transaction with this output as the new input. And then we can specify where we want to send these 84. Now let's just keep this simple. We're going to take this transaction ID, colon this, and then we're going to ask for a specific output, namely this one. And this is going to be how we build our transaction. So this is the first part of it. The second part of it is where to send it, and we're just going to send back to the same address everything except a single transaction which goes as transaction fee. So let's pick up this particular syntax, figure out the syntax. Help will give us more than one page, so I just want the first part of the head, of the help, so I pipe this into the head command. And here's the description of the create raw transaction command, and we just stick in the transaction ID, first the code and then the ID itself, and then the vout, which was 1. Now there's an error in the description here that says that you're supposed to set this up like an object, but in reality it's just the addresses and the data field that are listed. So here's the correct syntax. We're going to use, like I said, send 83 smileys to this particular address, and the leftover 1 smiley to make it 84 is going to be sent to the miner, or the miner is going to keep it. Now, in addition here, we also have the option of including a data field. So the data field consists of a hexadecimal code. So hexadecimals are just numbers, the numbers you would use if you had 16 fingers. So anything from 0 to 9, and then A is a 10 and F is a 15. So here we have 1 times 16 plus 15 as our data value, and whatever that means in ASCII or other terms is largely irrelevant. So let's create this transaction and see what it looks like. Let's also create the transaction without the data field. So this is an exercise in 2 things. It's an exercise, first of all, in creating a transaction with a data field, and secondly, seeing where the data field goes. And you can see what happened The short transaction without the data field ends with 88 AC and then a bunch of zeros. So here's an 88 AC and a bunch of zeros. And then attached to it becomes something called a 36 and then A0 or rather a 03, to say this correctly, a 03 and then a 6A and then a 01 and then an AF. Okay, so this AF here is what we proposed inserting. So now let's see what the rest means. Go back to our wiki page and check out the op return code. The op return code is 6A. So we just found a 6A right here. Okay, so that's our 6A. The next part of this 01 is the number of bytes in the data field, and we're only using a single byte. And then and this is how it's generated. So if we were now to generate one with AFBC, for example, then here's our AFBC, and it's now 2 bytes. And the 6A is the start of the op return. So this way we can insert any data field we like, and to actually send a message, if that's what we wanted, we would look up how to convert between ASCII and hex, and there are converters online for this kind of thing. So here, for example, if we wanted to write hello in ASCII, then to convert that to hex, we just press convert, and then we can put this into a data field. So here we have our raw transaction, and now we can do we can decode this. We can sign this transaction. Sign raw transaction, and this is now complete. It's ready for sending. So we take this complete transaction, and we need to send it, and it has been sent. And you can now look for this on the Inner Block Explorer. You can look for exactly this transaction once it becomes embedded in a block, which of course hasn't happened yet. But you can look for this transaction, and you can see that it actually contains the string hello. And to do it backwards, to do it using the wallet itself, you can also do that. You can simply say get raw transaction, and this is the raw transaction, and then you can ask the wallet to decode it. So you can say decode the raw transaction, and it will quickly tell you that there's an op return in this with this particular string attached to it. And then you go back to the ASCII to hex, and you reverse this process, and you swap these two, and you take this input, put that in as hex, and now ask it to convert that, please. And it says hello. So that concludes this quick session on how to stick data into the SmileyCoin blockchain.